Hello everyone. Today we're taking a look at LinkBERT, Pretraining Language Models with Document Links by a bunch of authors from Stanford University. Language models such as BERT are pre-trained on large quantities of text to learn various knowledge that is useful for downstream tasks. However, existing methods are unable to process and capture dependencies that span across multiple documents. This comes from the fact that these models are trained on individual isolated passages with no additional knowledge present to supplement each passage, to link it to the general knowledge about each entity, for example. For example, given a passage from Wikipedia that we have here in this figure about the tidal basin, which is a man-made reservoir, typically the BERT model is going to be trained only on this passage in isolation, without considering the useful information present in some other related passages. For example, here we have an entity, the National Cherry Blossom Festival, and the BERT will not know what this is when it's trained on this, even though we have a definition of the National Cherry Blossom Festival present already linked from this Wikipedia passage to the corresponding Wikipedia page. And this is information that is not used but can be useful for training the model to learn links between these concepts, capture dependencies better, which might be particularly useful for tasks that require multi-hop reasoning, such as multi-hop question and answering type of tasks that are very popular in NLP today. And this is precisely the focus of the authors of this current paper. They propose LinkBERT, a new model that has been explicitly trained on such linked passages to be able to use and relate the information better. There are two main novel aspects of the paper. The first one is that the authors create such a new dataset that contains such linked contexts. There's three main types of contexts in their novel datasets. First one is contiguous type of context, which is basically the same as the existing method for BERT, where basically you have a single block, a single article without any linking. They also have random contexts, where you have two segments from two different articles, but random articles. I'll come back to that in a second. And you also have these linked contexts, where you actually have two segments, texts from two different articles that are linked. For example, let's say you have document 1 precisely talking about the tidal basin, and you have document 3 talking about the National Cherry Blossom Festival. You would take those two paragraphs and combine them as the input context for pre-training BERT. So you have these three types of pre-training contexts. So that is one of the novel aspects of this work. The second one is that the authors introduce a novel auxiliary training task apart from the masked language modeling objective for BERT. This new auxiliary training task focuses on detecting when two passages are linked or not. For example, given precisely the example about the tidal basin and about the cherry blossom, what they do is they input those two passages and they train BERT while pre-training the model. They train it to classify these two passages either as contiguous, random, or linked in this case. And they do the same for random and for continuous passages. So the authors train then on these new datasets with new contexts, and they also have this auxiliary training task. And what they show is actually doing this leads to superior performance of BERT on a large number of tasks. And also it's important to mention as well that they focus on two types of datasets. One is more general purpose, where they use Wikipedia and the book corpus, which is the same precise dataset that has been used to train the original BERT models. But they also have a scientific LinkBERT, which has been trained on links extracted from scientific papers. And the authors train these models and they actually provide them, you can actually use them directly within Hugging Face in an identical way as you would use a standard BERT model. So you can go ahead and download those if you would like. Going to the results of the paper, the authors perform benchmarks on a wide range of reasoning, question answering problems. You have multi-hop question answering problems such as HotpotQA, TriviaQA. You have simpler benchmarks such as squat, but it seems that on average, when comparing BERT versus LinkBERT for various architecture sizes, from tiny to base to large, across the board, LinkBERT outperforms when fine-tuned on these tasks. So it's able to achieve better results across the board on those, which is nice, with several points. And especially the gap seems to be the largest for the tiny variant. So tiny LinkBERT seems to be much better than BERT, about 4 points on average, while only having 1 million parameters or so for both models. So these improvements seem to be quite big, and in particular they seem to be present for the multi-hop datasets, but even for the normal question answering datasets like squat or more standard ones. When it comes to scientific papers, the authors actually achieve new state-of-the-art on the Blue RB benchmark, which is a benchmark I'm not so familiar with, but I believe it's something to do with entity linking or with something like that, question answering potentially, but on biomedical data. So it seems that the LinkBERT is a very promising model with it can be used directly and gives improvements for this reasoning type of tasks. So it's a very interesting approach, and I encourage all of you to check out the paper. That is all that we are going to cover for this paper. Please like and subscribe, and I'll talk to you in the next one.